To build out our two-sum algorithm, we are going to start by defining it as a function called two-sum. And this function will take in two parameters, a number array and a single number that we will call sum. Although there are many different ways of building this algorithm, we will be building a solution that runs in constant, or O of n, time complexity. The first thing that we want to do inside of our algorithm is define an array to put all of our pairs into. So we will say variable pairs equals an empty array. Next, we want to loop through every number in our num array to get access to every number in it. So we will say for variable I equals 0, while I is less than numarray.length I++. And we will define the current number that we are on in the array by saying variable cur_elem equals numarray at position I. Now, this is where the main functionality of our algorithm takes place. What we want to do is we want to use a hash table and push every number that we iterate through into that hash table. In this algorithm, we will use an array as a hash table, but you could use an object if you would like to. They both achieve the same functionality. So on every iteration, we want to check this hash table to see if the current number's counterpart is present in that table. What I mean by counterpart is, let's say that our current number is 4, and the number we are looking to sum up to is 7. The counterpart of 4 would be 3, because 4 and 3 add up to 7. So if our current number is 4, we want to check our hash table to see if its counterpart, or 3, already exists in the hash table. If the counterpart does exist in the hash table, then we know that we have already iterated through that number in our array. We can therefore take these two numbers as a pair and push them into our pairs array. And that is just about all we have to do to get this algorithm working correctly. Let's write it out in code. So we have our current number defined here inside of our for loop. Now we have to define its counterpart. So we will say variable counterpart equals our sum parameter minus the current number. Now we have to check our hash table to see if the counterpart exists in it. So we will say if hash table dot index of our counterpart does not equal -1, or if it exists in the table, then we want to push our current number and its counterpart as a pair into our pairs array. So we will say pairs.push an array with our current number in it and its counterpart in it as well. Then outside of this if statement, we want to push the current number into the hash table no matter what. So we will say hash table dot push our current number. Then finally, all we have left to do is return our pairs array. And that is it. That is how to build out our two-sum algorithm in constant runtime, or O of n time complexity. Let's check to make sure that our algorithm works correctly by testing it in the next video. See you there.